Rightio then. So, as promised a little while ago, I've been on leave, bit of holiday, so just got around to it now. I've got a stove door, this screw here. I tried it on site, just didn't want to play. I can't remember if the others come out easily, but as soon as one starts sort of dicking around, you know it's never going to happen. So I've brought it home to do it in slow time with a cup of tea and all that sort of thing, so there's no real hassle, simply because obviously the gasket, as you can see, the old ceramic paper type gasket is shot, so I'll replace that with another one. But the idea of this then is to show you what I do to get around drilling out and re-tapping a new thread. What I'll do is go through the tools that I use and how to do it and sort of different ways of doing things, and sort of slow time go from there. Now, I'm no sort of YouTuber or content creator or whatever they're called, so I haven't got any editing stuff to try and stitch this together at the moment. But what I'm going to try and do is have a word with any sort of geeky friends, see if they've got something that I can use to create this a little bit better than it's going to be. So if you bear with me, this is what it's all going to be about. Whilst I'm here at the moment, what it can do, as you'll find later on, or as you'll see later on, sometimes when the head shears off, it will leave an uneven surface for the shaft of the machine screw. So if you were to try and drill it, you'd be all over the place. Ultimately, you end up centre popping it, so it creates an area for the drill bit to engage into and then start to drill as you make the hole bigger with different size drills. But sometimes, as you can see, this is well placed. You've got sort of a hole there already and it's pretty much in the middle. Sometimes what you can do is kind of round that out so it's not a jaggedy hole that might snag the drill bit. Sometimes you can round it out and that creates like a nice sort of cone shape for the drill bit to sit in. So again, as I say, it's something I'll talk about as I'm all set up ready to go, and we'll see what happens. All right. Okay, so now that I'm set up, I've got bits and pieces. I'll talk through the stuff a little bit later on as we come to it. One of the things that I use a lot of, that's brilliant, I've been using it since I was in the Navy, so Christ, for probably 30 odd years, is this stuff, Plus Gas. It's brilliant. So it's a penetrating fast release fluid. It basically works on sort of capillary action, so it finds its way into little gaps and then helps unseize the seized. I've used it on manifold nuts and bolts and all sorts of things on engines that I've played with in the past, as well as all sorts of kit on board ships. This is another one that I'm trying. I got it, I can't remember where I got it from, like a motor parts, not Euro car parts, but like another motor factors, so give that a go. So the reason why this stuff, these things are so effective, and I touched on it just now, capillary action, is aided by a little bit of heat. So I've got a little dicky blowtorch thing here, little smally thing. It's just filled up with butane lighter fluid, and I've obviously got the biggie map gas jobby. So what I've done with this screw in particular, it's still a bit warm, applied a little bit of heat with this little dicky one, and if I just get it going, I'll show you. Right, the spark thing isn't working on it, so I've got to do it old-fashioned way. Put the lighter. Let's try again. Here we go. So when people say apply a bit of heat, what you want to try and do is apply it locally to where the issue is. So if this screw is seized within the hole, it's because it's just corroded together potentially. So what you want to try and do is create a gap between the screw thread, the male thread, and the hole thread, the female thread, to allow the penetrating fluid to get within to the gap. So to do that, you need to expand the female bit as it were. So when people say just blast it with heat, all you're going to end up doing is expanding them at the same rates, which isn't going to work too well. So if you can apply controlled local heat in the area, and that's why I've got this little dicky thing. It's not going to be setting it off to red hot. You don't need it. You just need a reasonable amount of heat just to expand the female part, as it were, for and that then will allow, you know, a microscopic gap to open between the threads, which would then allow the fluid, penetrating fluid, to pass within it and penetrate. If I can get gusset and moist in there, I will. So yeah, so it's just a case of applying a bit of heat. As I say, that then just creates a little gap, an expansion gap, which then allows the penetrating fluid to get on in there. That's the theory. Sometimes it works, sometimes it doesn't, and when it doesn't, you end up having to go down the course of action of drilling and cutting new thread. So I'll give this a few more moments. I did apply a little bit of the Plus Gas just now. I then went off and made a cup of tea, came back, so it gives it a few moments just to, or a bunch of minutes to sort of work its way in. And now I'm just going to, as I say, apply some heat, and then what I'll do is apply some of the other penetrating fluid, as I'm sort of experimenting with it at the moment. Hopefully that would have made its way in there. Now the posi recess on this screw is a bit nadgered, so normally posi number 2 would be fine, but as you can see there's a lot of movement there, and the screw hole, so I've gone for posi 3. And I have to apply a bit of weight on that. Looks like magnetic. That's a little bit closer. Oh, just while I'm here, these screwdriver sets, I got this in Lidl's. It's one of the Parkside things. I thought it'd probably only last a few goes. It's bloody brilliant. You've got a whole host of different sort of adapters that will go onto like a little hand ratchet jobby when it's in the right position. So that's useful, and a whole host of other sizes and things. So I think it's about 22 quid, 25 quid. As I say, I thought it would only last a few goes, but no, it's done really well. And even these little jobbies, they'll fit in the end of that. So it's quite useful for baffle nuts and bolts and things. Right, let's give this a bash. So put a bit of weight on there. No, that's not going to go at all. So what I'm going to do is round that out a bit. There's the pudding. What I might try is my grips. Give me 2 moments, I'll grab those. Right, so screwdriver variation didn't work. So now I'll try the set of grips, just to grab onto the side of the screw and give it some yahoo. Confidence isn't high. Well, I'm buggered. There you go, look. So, don't know whether it will come out. Nice and easy. Catchy monkey. Right, I'll carry on with that and see what happens. If it does shear in the end, because it may jam and shear anyway, it may just be the head of the machine screw twisting on the shaft of the screw. We'll see what happens. Okay, so the other door that I was working on turns out went okay. All the machine screws came out by using the grips in the end, and I've done that, and that's there. So I've replaced all the machine screws with stainless steel shouldered M5 Allen bolts, machine screws. Replaced the glass seal and done the door seal as well. So that's that one. Happy days. So for instructional purposes, I've got in the garage an old Stovax Stockton ship box that I took out from a job a while ago, and a lovely little Clearview Pioneer 400, which is in the state inside. They'll be useful for other stuff later. So I know the Stockton for instructional sort of stuff. I'm going to drill out and tap one of these, probably this one, because it's easier to get to. I've had a bit of a play with them. Other than this one that's a little bit loose, that will come out freely, all the others are seized. I did have a bit of a nibble with the grips, the same that I did with the Love and Home type thing. This one freed a little bit, but these are well in, so it will be old school drill and tap. So how do I do it? I suspect, like most of them, they're M5. It's a metric system, so M is millimeters, 5 is the diameter of the screw, size of thread. So I've got here, and you'll never see it. Oh yeah, you can just make it out. M5 set of taps. Now, taps create the thread, and I'll show you those in a minute. And then you've got a selection of drill bits to make the size hole required for tapping. Now, this, again, Lidl's, unbelievable. I got this from Lidl's for a couple of quid. I thought it would probably only last a couple of drills. It's been amazing. They're decent little drill bits, actually. As long as you use a bit of cutting compound oil, then they go well. So, because it's an M5 hole I've got to create with the thread in, you have to have a certain size hole for that thread to cut into, and in this case it's 4.2 millimeters. You could Google it, what size hole you need for M6, M8, M10, M5, M4, M3, whatever, and there's a specific drill bit size. So I know from my experience, 4.2 mil drill bit, and that's what I've got. So I've got a bag of drill bits, some spares just in case, because 9 times out of, you can end up snapping them, whatever. So they're there, so I've always got a load of those. And I've got a whole bunch of M5 machine screws. So what I'm going to do is get my able assistant wifey to hold the camera for me whilst I do some pointing out stuff. Right, if you keep it around there. So just to confirm, first off, see, this one comes out beautifully. I've got myself, from back in my time, a set of vernier digital calipers. They're brilliant. It's in millimeters. It's going to be awkward trying to look in the camera and look at what I'm doing. So across the diameter, 4.82, 4.8. That's fine. That's basically 5 mil. I could prove it. I'll show them one of these. And get it out. A little bit less or a little bit more, it's 4.9. So that's probably down to a little bit of corrosion and wear and that sort of thing. tenth of a millimeter. I'm not going to worry about that. So I know now that these are going to need to be holes that are going to require a 5mm tap. So ultimately they're going to be drilled out to 4.2mm. So the taps, this is them. This is the handle that they go into. I'll show you how they all go together. So taps, there's 3 different types in the box. I haven't got my glasses on. So with taps, you've got a primary, a secondary and plug. The primary is what starts the thread initially. If you were to have a look closer, and it's always going to be rubbish on the camera, but you've got less cutting thread initially. It kind of eases itself in on the shoulder of the tap. The secondary tap has got a little bit more cutting thread initially. So the cutting thread on the secondary starts probably about 4mm down, whereas on the primary it starts around 6mm. So it's leading itself in like a leading edge. As I say, secondary, a little bit more cutting thread initially, and then the plug tap, that's got cutting thread all the way from the start, and that would take you down to the bottom of the hole. So those, once I drill out the hole in that, just fit into the T-bar type chuck, and then a little bit of cutting fluid, which I've got over there, I'll show you later, and then you should wind it in. And when you're doing it, you're actually cutting metal, so you want to try and do like half a turn, then quarter of a turn back, then half a turn again, then quarter of a turn back, then half a turn again, then quarter of a turn back. And what that does, that stops the metal building up behind this, creating a blockage almost, which can then over torque this, and then you end up snapping the tap within the hole. And if you get into that situation, you've got a whole load of problems, because these are high speed steel, which is the same as your drill bit set. So trying to drill one of these out, you've got no chance. You're better off trying to re-drill a new hole and then threading that and starting again. So that's those bits. What I'm going to do is get set up on one of these screws, and then we'll be back to do the drilling-y stuff. Okay, so we're all good to go. We do have a guest appearance. The dog's turned up just to say hello, so Toad will probably get in the way. Right, so as I was saying, I need to ultimately drill this out to put in a 5mm screw. So to do that, I've got to make my way up towards a 4.2 drill bit, which is this kiddie here. I'm going to start, so basically creating a pilot drill using a 2.5mm drill bit. And what I'm going to do, and the way I'm going to achieve this, is simply by starting in the posi drive screw hold kind of thing for the screwdriver. Hang on, Poxy dog. Right, so can't remember where I was now. Ultimately, I'm going to try and drill my pilot hole drill back in the screwdriver recess on the machine screw. Now, if you get to the point where you can't use this and you've got to grind that off or whatever, ultimately you're going to end up with a flat surface. If you were to try and drill a flat surface that hasn't been marked, then the drill bit's going to move all over the place and you're never going to get it accurately. So this is where a little dot punch comes in. Now this one's what's classed as an automatic dot punch. You press it, and then after a period of, after some applied pressure, it will suddenly release and make a clicking noise and make a little indentation. Or you can go old school, and it's basically just a handheld one with a hammer, dink, centre pop it. So I'll show you in this bit here what it does. So let's just take the camera, the phone. As you can see around here, there's no marks. If I use the dot punch, do it a few times. Once I take that away, you should see, there you go, look, there's a little indentation in the metalwork. Now I could put the drill bit on there, start the drill, and it's not going to move anywhere. Whereas if I was to try and drill elsewhere, it would move around. Because basically, if I show you on a bigger drill bit why there's a problem, on a drill bit, if you were to look at the end of the drill bit, the very leading pointy bit, it's called the chisel edge, that's flat. So if you imagine trying to turn, spinning a flat thing on a flat surface, it's going to scooch about the place. So there we go, dot punch. I'm going to do a couple in here just to make sure, and if nothing else, just clears the muck out of it. Right, wifey takes that. So what I'm going to do is just pop a little bit of cutting compound oil in the hole, and I'll be stopping and starting relatively regular doing that. And as I say, I've got a 2.5mm drill bit in there just to make a start. Now you don't have to go balls out speed, just nice and steady. Trying to keep the drill nice and vertical. Ideally, be doing this in a vertical drill machine, pillar drill, that's the word, but you don't have those in the back of the van. There we are, starting to cut now, got a bit of pressure. I've only gone in a few mil. I'm going to put a little bit more. Let's give it a little flat screwdriver just to clear the muck off. Steel screwdriver, or sorry, steel screw, because all the swarf stuck to the screwdriver. Magnetic tip. Right, drop a bit more oil in there. There we go again. Again, clear the muck. It's not a 5-minute job, this. Hopefully, by the time you're watching this, I've figured out some way of editing software to speed it up. Otherwise, you're likely to slip into a coma.
I can just forward it in.
That's it. Now in a minute, I'm going to gauge on my drill bit how deep I am in comparison to the machine screw that I took out. And that'll give me a good idea then of when to stop, because the last thing you want to do obviously is go through the fabric of the door. So where is it? There it is. So from there to there, it's about 10 mil. Just there. And I'm currently about 6 mil in. So like I say, this is purely just a pilot, and then I'll end up increasing the size drill bits. But like anything, the more care you take initially makes your life a little bit easier later. There we go. So I've just gone through the machine screw, because at the bottom of the machine screw thread there's probably about a 2mm gap until you get to the back of the door material. Just clear it out. Great success. So that's a good start. So what I'm going to do now, as I say, I need to ultimately get up to 4.2. So I've just gone 2.5. So I'm going to go for the 3.5mm drill bit. Which is that one there? So again, dollop of oil, and at some point the head of this screw, the original head, will break off, because the drill bit will end up either, or the equivalent size, and then it will just break away. There we go. So that's that. And now I'm going to go for a 4mm drill bit, because at least then the last cutting piece will only be 0.2. So it doesn't put too much strain on the final drill bit. Again, more lube. Beautiful. And now finally the 4.2, which is ultimately the size of the cutting thread, the M5. Alright then. Beautiful. Okay. Quickly roll. Now, it's not going to take much for that to break off. I shouldn't do. So, let's see what happens. Yeah. So that's quite interesting. I don't know if you can see it in the video, but that head's still there. So the remaining material left is hard to see. There we go. Very minimum, or very minimal thickness left. So that is basically the thickness of material that the tap's going to cut the thread into. So in that hole in there will be some sort of remnants of the original screw that we've just drilled out. Hopefully if I can clear that oil out. It's beautiful. Beautifully drilled hole. So, one of two things may have happened. The original machine screw material may have come out with the drill bit when I was cutting, which may not leave much material in there to thread, which means that the existing thread, the original thread, may be in there that is usable. So what I'm going to do is, just to clear the thread anyway, we'll use the primary. Oh, would you believe it? So again, a little bit of copper oil, not copper grease, that's later. So I'm going to go straight in with the plug tap. Beautiful. And because there's minimum material in there that needs cutting, that's why I didn't do the half turn in, quarter turn back that you would normally do if it's a new virginal hole that you're going to be tapping. Because in this case, the amount of swarf build up on the tap is so minimal, it doesn't warrant it. You can normally feel it anyway, you can feel the build up. See, I can feel a bit of torque coming on that now. That's why I'm going a little bit steady. It's probably where it's at the bottom of the hole now. So that is that. Good. Right. Let's see if I can clean that out a bit. Let's use a smally screwdriver just to pop that a bit more. Sorry. Right.
Again, here you got the dog.
That there is a nice thread that's been cut in that. And now I've got a new machine screw. Let's just test that thread. Beautiful. Engineering magnificence at its best. So there we go. That screw hole, the original hole, is perfectly centralized, simply because I was able to drill straight into the original machine screw. But if you're not that lucky, if it's sheared off and you've got a stub of let's pretend that's sticking out the top there, it's sheared off, then in that case what you end up doing, get your angle grinder, grind it off flat, and you will see a difference in materials with the grinder, and that's when you then get your dot punch, get it in there central, couple of dots, and then you've got a perfect little indentation in the material to start your drilling with. And that, ladies and gents, is, in simple terms or basic terms, how to drill and tap if you have a sheared screw, whatever, or seized screw. That's it. Right, one thing I didn't mention is, once it's all been drilled out and you're ready to put all your machine screws in and put everything back together and everything's all hunky-dory, what I always do in the threads is I put a little bit of wipe of high temperature copper slip. Again, it's the sort of stuff you can buy from motor factors, Euro car parks, wherever, car parts, Halfords, wherever really. But I always go for the assembly grease. it's got a very high melt point, something like 1300 degrees, something in that sort of area, and it just prevents stuff seizing together, ferrous materials. Now obviously I'm using stainless steel screws, so you shouldn't have the same issue as you get when you're just using normal ferrous machine screws. But what I do, I just get a little sort of smally terminal screwdriver, like a watchmaker's jobby, just a little blip of it on the end of the blade, and then dab it into the hole and just run it round. Just like that. Sorry, I don't know if my hands was in the way then. That's all I do, just rub it around so it distributes in the thread. And then let's pop that there. Again, tricky because it's just me doing it now with the camera. Yeah. And then that's just enough. I wind it back and forward a couple of times. A little bit of a pinch and a bit more. And that is her. So, copper slip on your threads after every job. That will make your life a little bit easier if you go round to do another door seal or glass seal at some stage. And it's the same on any of the threads really. I use exactly the same stuff. This is what I use on Chesneys, on the thread on the handles. I'll strip them down. You know, I've had one where it took me, Christ, probably 45 minutes to get a handle at the door because it was tight. Then once it eventually came out, horrendous noises, squealings it was making. Once it's out, clean it all up with a wire brush, and then a wipe of the copper slip, put it back in, do it all back up as normal. Happy days. And she sounds better, the action, the movement is better. And there's been a few customers now I've gone to recently. One, for example, it's the third time I've been to them now, because I've only been doing this a short while, but it's the third time I've been to them, and the door handle came apart beautifully. And each year I do it just to give that kind of future proofing it, or whatever you want to call it, really. A bit of maintenance, preventative maintenance. An extra couple of minutes at that time saves, well, best part of an hour of heartache in a bunch of years if it all seizes up. So that's it. There we go. All right. I hope that's been useful.